So we're going to be venturing into Chapter 12. We're going to kind of jump around in it a little bit. I want to make sure that we highlight things. And I do need feedback because some of the things that was written in the placement test, what's going to be on the placement test, we kind of get like a rubric of things that are going to be on there. It does talk a lot about box plots. So that was back 6th grade, and you should have done some last year. In fact, Mr. Mason said you guys did double box plots. So those are the ones where you find the 5 key pieces of data, and you've got a box, and you've got whiskers coming out of it. They used to call it the box and whiskers plot, but now they just dropped the whiskers part, and they just call it a box plot. So we will go over that to remind you, but I will let you know that if you go back to the 0 chapter, the beginning of your book, they do talk about the box plot. So you might want to do that on your own. So today we're going to focus in on lesson 12.2, and the statistics we're going to look at are let's go. Statistics intro. And we're going to talk about mean, absolute, deviation, and we're going to talk about standard deviation. And we're at 5:16. Nope, we're at 5:17. The year is 16. Okay, so first thing we're going to go through some words. We're going to remind you some things from the past. First vocab word came from last year, and that's univariate data. Uni means one, variate means variable. So this is something that the data is only talking about one thing. So in words, they say this is the measurement data. So we've got data in one variable. So there's one thing we're looking up. The data we can actually physically measure because it's numbers. So this would be the sorts of things like in the classroom figuring out everyone's height. So we get a height number from all of you, or a weight number, or a birth year and months, how old you are number. So we're getting physical raw numbers so that we can do math with it, okay? So the math that you guys are used to doing is the measures of central tendency. And you've been doing the measures of central tendency for years. So measures of central tendency, things that measure what looks like the center. In other words, what is average? We actually have 3 statistics that you guys have worked on that are trying to tell what average looks like for that set of data. Those 3 are mean. Maybe if I could spell correctly. Mean, median, and mode. Okay? Mean, median, mode. They all mean average, but they mean it in different ways. Mean is a calculated average. It's how your grades are calculated. We take all the points you've earned, divide it by how many points have been possible, and that gives us your percent. Okay, so that's your mean score for this class. Median is what's the score in the middle. Okay, it's physically line everything up from least to greatest, look for the middle. Most is the one you guys like because this is the words that I hear. What's most popular, most attractive, most desirable, whatever. It's the thing that shows up most often is average. So the problem with measures of central tendency is you can all encapsulate them under one word called average. And when you read in magazine articles or newspaper articles and they talk about the average salary, the average American, you don't know which of these central tendencies they're using, and it can be very, very misleading. We had an example in the in-service I was in, and they were talking about, let's say there's a job posting and they said the mean or the average salary is $150,000. So, a kid fresh out of college is going, yeah, baby, $150,000 a year? That's awesome. I've never made anything remotely close to that. They interview, and their starting salary is $30,000. And they're like, what? Well, what didn't come across is that the CEO's salary, which is in the millions, was also part of the calculations. And so it skewed the data to look much better than it actually did. It raised the mathematical average. Median is a better choice there because you list everybody's salary and what's in the middle makes sense. It gets rid of what we call outliers, the guys that stretch the data either to the right or to the left. Mode is just popularity. Okay? And popularity is very skewed because it depends upon the group you're talking to. There's an example in the book about asking questions at a country western, let's say, award show, and then ask them what their favorite radio stations are. Well, most likely, most people who are attending that concert are going to pick country western stations or this award show, because those are the people who like to go to the award show, the people who like that kind of music. So that could be very skewed data. If they said the average American loves country music, where do they get that from? Well, they went to this one source and got some information. Okay. Now the other ones, we also have talked about some of them, but not all of them. And these are the ones called the measures of variation. So they're looking at how does the whole group of numbers vary from one to the other. Okay? So you have done things like range. So what's my largest, what's my smallest? Let's figure out the difference. Okay? When the range is large, that means the numbers are pretty broadly spread. When the range is small, that means the numbers are pretty close to each other. Okay? You've also, remembering back to your box plots, we talked about quartiles. And then also associated with the box plot are the interquartile range. So quartiles, in a box plot, you have 5 set pieces of data. It breaks your data into 4 big groups. Okay? And then the interquartile range is what is the largest number in the box to the smallest number in the box. So again, we'll go over that, but look at the chapter 0 for that. Interquartile range. So the ones that we're going to talk about, though, are called mean absolute deviation, lovingly referred to as MAD, and standard deviation, which I'm going to refer to as SD. Okay? So we're going to start with mean absolute deviation, and we're going to start with numbers that are going to be easy to deal with in the examples. But what I want you to pay attention to is, yes, you may use a calculator. The math we're going to do gets pretty complicated, so using a calculator is going to expedite your ability to solve these problems. Okay? So I'm going to give you a scenario. Is everybody good? May I move on? We good? So the scenario I want to go through is an example 2 in your book, and it talks about people going onto a comic book store website, and they wanted to figure out how many comic books those people bought each month. So in one particular day, they received the following responses. So remember, this represents the number of comic books bought in 1 month, and there were 5 people who responded. And the responses were 2, 2, 3, 4, 14. Now, I'm going to be honest with you. They didn't come in this order. They came in willy-nilly, but then the numbers were put in order from least to greatest, because that's always the first step when we're doing any kind of statistics, is to put them in order from least to greatest. Now, it kind of reveals something interesting straight off the bat. What do you see that's interesting about these numbers, Marlene? Yeah, they're pretty clustered until you get this 14. It's a huge gap from the other numbers. From 2 to 4, it's a range of 2, but when you throw in the 14, now we're talking a range of 12. That really doesn't represent the data very well. So this mean absolute deviation is going to help us to predict errors. So let's write over here, MAD. It's going to take out that whole idea of what am I looking at. So it's used to, oh, come on you, to predict errors, and then also judges how well the mean represents the data. So this one focuses on the mean. That's what the M for MAD stands for, is the mean. So we're going to be calculating the mean. In fact, we're going to calculate two means. And we're going to look at what that mean, how we can interpret it. Is the mean really a good judge of the information we have? So it kind of works like this. You start by find the mean. And you're like, well, that's pretty easy. I just take 2 plus 2 plus 3 plus 4 plus 14, and I divide it by how many numbers I had? 5. And you get the mean to be 25/5, which equals 5. So we have a mean of 5. Now, looking at this numbers, is 5 representative of the data? Not really. The numbers are between 2 and 4, the majority of them, and we get a mean that's higher than that. It's like that boss's salary skews what the pay rate is. Okay, but we're going to go deeper. So what we're going to do is we're going to find the absolute differences. So what does absolute mean? Where have you heard absolute before in math? Absolute value. What kind of answers do we get when we use absolute value? We always get positives. So we find the absolute difference. So absolute means positive, and difference is we're going to subtract two numbers and then take the positive version of it between the mean and each value. In the data. So it looks like this. I'm going to take, and it doesn't matter how I do this math, to be honest with you. It doesn't matter if I take the value from the data and subtract the mean, or I do the mean and subtract the data, because I'm taking the absolute value, so it doesn't matter. So I'm going to go with the mean in front, and I'm going to subtract 2. The absolute value of 3 is 3, so I get a 3. And then I take the absolute value of 5, take away 2, and I get a 3. I take the absolute value of 5, take away 3 is 2. I take the absolute value of 5, take away 4 is 1. And the absolute value of 5, take away 14. Well, that actually gives me -9, but the absolute value says 9. Okay, so that's my second step that I do. Now, we're going to add the differences. Now, when I say differences, I'm talking about the absolute differences. So we get 3 plus 3 plus 2 plus 1 plus 9. And that gives me, what, 10, 16, 18? So I get 18. Yes?
On the second step, on the last row, numbers minus, is that 141?
No. It's the absolute value of 5 take away 14. It's not 15 take away 141. Absolute value signs. That's where the word absolute comes from. Okay? Now, the last step is we got to get MAD. Okay? So how do we get MAD? Okay? So what we're going to do is we're going to find the mean. So I'm going to do another add up and divide by kind of thing. Mean, absolute, so it's got to be positive, deviation. That's its name again. And what I do is I take the mean of the differences between the mean of the data and each value. So that goes on top. And I'm going to divide it by the mean we had of the original data. So 5 goes into 18 3 times, which is 15 with 3 left over. Oh, sorry, that's supposed to be a 5. Or we can write it as 3.6. So what does that 3.6 tell you? It basically is saying that on average, each value is 3.6 units away from the mean. So that means 2 is 3.6 away from 5, 3 is 3.6 away from 5, 4 is 3.6 away from 5, and the answer is nuh-uh. And that's because what Marlene mentioned was the outlier. Okay, so this is basically saying this is not a very good set of data. So mean bad. Okay? Yes, sir.
And would you rather us answer like 18 over 5, 3 over 3?
You would go to decimals because whenever you do statistics, they like it to be usually at least to the nearest tenth because it's more precise. Okay, so we don't use fractions when we're talking about stats. All right, so we're going to quickly talk about standard deviation, and I'm just going to it's very similar in terms of process, but it does, standard deviation, it does change a wee bit. So we have recorded the lecture in first period, and we did go through the steps. We didn't do an example of it. So standard deviation is, again, dealing with the mean. So low standard deviation, numbers are very close to the mean. High standard deviation, the data is spread out really far away. Okay? So here's this first step. You find the mean of the data, just like we did with MAD. Okay. Second step, we're going to find the square of the difference between each data value and the mean. So we're going to do the same thing in step 2, but we're going to add something to it. So we're going to find the difference between mean and each data value. And then here comes the change. And square it. Okay, so that's a big difference. We're not just taking an absolute value, we're squaring it, which removes the negative, right? So we still are going to end up with all positive numbers. So that's the next step. Then we're going to add all of the squared differences. We did that. We're going to find the mean of the squared differences. So we take step 3 and we divide it by how many data items we had. And then this is, again, another reason why I said you can use a calculator. Now you take the square root of the mean of the squared differences. A lot of times when people are doing a test, they find the mean of the data, and then they figure out what one standard deviation above and one standard deviation below would look like. And 68% of all people should fall between one standard deviation. Okay, and then it branches out. So tests follow the bell-shaped curve, and we'll talk more about that. So again, what we're looking for is another mean. So I don't have an example, but we do have these steps, and then you guys are going to work on them. So yes, use a calculator on this, but you got to show me what's going into the calculator. Okay, so you can do it step by step like the MAD, and then like for this one, what I would do is the step by step for the MAD, and then square those differences, just in a kind of like column format. And we'll talk about a kind of a chart format that might help you organize your information as well. The downfall, and the other reason why I get to use the calculator, is when we're talking about this kind of data, it's usually not 5 numbers. It's usually a lot of numbers. Okay? All right, that's it.